Good morning, Algebros. Today we are going to continue analyzing graphs and looking at the different aspects of graphs. And today we're going to look at increasing and decreasing intervals. So when we read a graph, we read it from left to right, just like we're going to read a book. And I always kind of like to think about I'm getting on my line roller coaster and seeing where it takes me. So if I get on my roller coaster here, click, 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 going up. And since we're reading graphs left to right, we're looking at those x values. So we're reading it between our x values, but the y values are telling us if we're increasing or decreasing. So from 0 to 2, we are increasing. So we write it as an inequality. So from -1 less than or equal to x less than or equal to 2. That is the interval that we are increasing. And I'm using the equal to line because they are solid points and there's no break in the graph. It's continuous. So I get up to the top here and I go back down. And I'm decreasing from an x value of 2 to an x value of 4. Notice that my inequality signs are facing the same way. If you write the smaller number on the left and the larger number on the right, it will always look like this. So from here we change directions, click, 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 click. We're going back up and we are increasing from 4 to 6. And here we change directions again. We go down and we are decreasing from 6 to 8. And again, we're using the x because we are talking about intervals between the x values. And here we change directions. Click, 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 click. We're going up from 8 to 10. And we change directions one more time. And we stop. So from 10 to 11, we are decreasing. Right, example 2. It is possible to have an interval where the graph is neither increasing or decreasing, and that is called constant, where you're not going up or down. Right, so if we get on our little line roller coaster, we're click, 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 we're going up. So from 0 to 10, we are increasing. Then once we get up there, they want to increase the suspense of the roller coaster. So we're just kind of sitting at the top for a little bit. So from 10 to 15, we aren't going up or down. We're staying consistent. And then all of a sudden, we take off. And we're decreasing from 15 to 40. And at 40, we click, 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 and get back up to the platform, and the ride is over. So from 40 to 55, we're done. So you know how some roller coasters start on a platform, and then the dip goes below the platform, like it goes deeper than where you started? So that would be what would happen here, and then you got to come back up to the platform. All right. So those examples have ending points. But what about a graph that's continuous? Like this one in example 3. So we're still reading our graph from left to right. So remember, we're coming all the way from down here, way up here. So we have we're coming from way down here. We're coming from -infinity, and we are increasing all the way to -2. So even though this arrow is facing down, we are increasing because we're reading this graph from left to right. So we're going up. So we're coming from -infinity. So anything that's less than -2, we're going to be increasing on. so we're going to say x less than or equal to negative 2. And you could, do the complex inequality, but when you're talking about infinity, just a single inequality like this will work. At negative 2, we change directions, and we go down to positive 1. So from negative 2 to positive 1, we are decreasing. So again, because we're between 2 points, two definable points, we have that compound inequality. And at positive 1, we change directions, and now we are increasing again. So from positive 1 all the way to positive infinity, forever and ever, we're going to be increasing. So we would go, we're at 1. 1 less than or equal to x. So x tells us it goes on forever and ever and ever. Let's do a few more examples. All right, so our domain is where our graph exists left to right. So because it's going to continue to get wider and wider and wider forever and ever, it's never going to stop. Our domain is all real numbers. Actually, I'm going to stop this video so it doesn't get too long, and I'm going to do example 4 and 5. In my next video, example 4 and 5 is going to look like your homework. So I would stay tuned and watch it.